My best wishes to everybody for a happy and prosperous 2024. We are going to discuss the paradox that we started last time. We saw one part. Today we are going to see some more of those. Particularly, the stuff that we are discussing are interesting for those students and all those persons who are new to complex analysis, particularly complex algebra. So today, let me start by seeing three identities. The three known identities are log natural of exponential x is equal to x, z to the power w is equal to exponential w log natural z, where z is a complex number, and e to the power I theta is equal to cos theta plus I sin theta. These three identities we know well in our high school days, higher school days, or higher secondary. From that, those days, we know these three identities pretty well. Now, let us use these three identities. Uh, for the Euler identity, let us write theta is equal to 2 pi. We have seen this last time. Then e to the power 2 pi I is e to the power theta is e to the power 2 pi I. So that will be cos theta or cos 2 pi plus I sin theta, that is sin 2 pi. So, sin 2 pi is 0, cos 2 pi is 1. So this will be 1. So 1 is equal to e to the power 2 pi I. Let us start with this next. So we have now seen 1 is equal to e to the power 2 pi I. Now what we will do is take logarithmic on both the sides. So left side we take log, right side we take log. So log 1 is equal to log of exponential 2 pi I. Next. Now log of exponential x is equal to x and log of 1 is equal to 0. Now on the left hand side we had log of 1. So that is equal to 0. On the right hand side we had exponential log of exponential 2 pi I. So x was 2 pi I. So that will be 2 pi I. So left hand side is 1 is 0, right hand side is 2 pi I. So 2 pi I has to be equal to 0. Is that possible? Again, we have seen another absurd answer. As we saw one absurd answer earlier, as 1 is equal to minus 1, this is again an absurd answer. But it is a paradox. Where have we made any mistake? Have we made any mistake in deriving this? Let us see another one. We know what is I. I is root over of minus 1. That is the imaginary number. Now I we can write as I is equal to I to the power 1. So 1 is 4 by 4. So we can write I is equal to I to the power 4 by 4. Now as we know, x to the power mn is equal to x to the power n whole to the power n. So in that formula we will use this. So I to the power 4 by 4, we can write it as I to the power 4 whole to the power 1 by 4. Let us start from there. So I is equal to I to the power 4 whole to the power 1 by 4. Now I to the power 4 is I square to the power 2. So I square to the power 2 whole to the power 1 by 4. Now I square is minus 1. So minus 1 to the power 2 or minus 1 square whole to the power 1 by 4. So I is equal to this. So I is equal to minus 1 to square whole to the power 1 by 4 minus 1 square is 1. 1 to the power anything is 1. So 1 to the power 1 by 4 is equal to 1. Therefore I is equal to 1. Now we have seen I is equal to 1. But we know I is equal to root over of minus 1. So I is equal to 1 or I is equal to root over of minus 1. So this way we have got another absurd answer as I is equal to 1. So up to now we have seen three absurd answers. Let us see some good answers, proper answers. So let me start with theta is equal to pi by 2. If theta is equal to pi by 2 using Euler formula, we get e to the power pi by 2 I, that will be cos pi by 2 plus I sin pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1. So e to the power pi by 2 I is equal to I. Next. Then there is another identity that we have seen. If z is a complex number, then z to the power w is equal to exponential w log natural z. So now let us take z is equal to I, the imaginary number. Then if I put z is equal to I in this identity for z, then z to the power w becomes I to the power w, e to the power w log z becomes e to the power w log I. So I to the power w is equal to e to the power w log I. And now in that, let us put w is equal to I. If we put w is equal to I, then I to the power w is equal to e to the power w log I. In that we have put I is equal to w. So left hand side becomes I to the power w, that is I to the power I. Right hand side is e to the power w log I. For w I put I. So right hand side is exponential I log natural I. Now, left hand side, let us keep it as it is. So that is I to the power I. Right hand side is e to the power I. Then log natural e to the power I pi by 2, because I is equal to e to the power pi by 2. So log natural I is log natural e to the power I pi by 2. Okay, log natural e to the power x is x, so we will put that in log natural e to the power I pi by 2. So if you do that, then right hand side will become e to the power I into, for log natural e to the power I pi by 2, we will put I pi by 2, because that is x. So e to the power I into I pi by 2. I into I is minus 1. Therefore, I to the power I is equal to e to the power minus pi by 2. So this is the correct answer. This is not a wrong answer. This is a correct answer. But the procedure that we used in deriving this or getting this is wrong. What we'll do next time is see why this procedure is wrong and why we were getting absurd answers. That will start from the next time. Thank you.